YouTube, in this video we're going to discuss how to find the absolute value, or what we're going to be referring to as the modulus of a complex number in standard form. Okay, so when we discuss the absolute value of a number, recall the absolute value of a number in a linear sense. That is, back in the day in algebra when we say things like what is the absolute value of 4, what it's really asking is how far away from 0 this number is, say in a geometric sense. Okay, so if we said like 4, 1, 2, 3, 4, we could say that 4, of course, is 4 units away from 0. And I just want to point this out. If we were to do -4, this is why when we do the absolute value of -4, say, which is right here, we also say that it is 4 units away from 0 because we refer to distances as always being positive. So what we're going to be doing is much the same thing. We are going to say that the absolute value or modulus of a complex number, and we call this complex number z, we refer to this complex number in standard form as some x plus yi, though let me try to fix my layers here. That way I can draw on it. So we say z is this x plus yi, so we have some real part plus some imaginary part here. We say that the modulus or absolute value of this is the distance from that origin to this point x, y, okay? So we say this distance is denoted by r. We've used this letter r to denote this distance before. And we say that r is really the absolute value of z. We could write it as absolute value of z with these bars around it, these absolute value bars. We could also say it's the absolute value of x plus yi with the absolute value bars. But you'll notice that I write here, it's the square root of x squared plus y squared. Now this is something that I've seen before. As a matter of fact, I'm going to go ahead and point this out here. But we say given some complex number x plus yi, we could say if we were to graph this thing, recall that the x-axis is our real axis and the y-axis is our imaginary axis. So we get some number that would be, say, maybe right here, this is some point x, y. But the idea is if I'm drawing, say, some vector here, we could split this up into its parts being x wide and y tall, and this is some right triangle. So we'll say that the absolute value of this, first of all, the absolute value of this number, absolute value, we want to label this, is the distance from this number back to the origin, okay? So we say the absolute value is this distance right here. Also this, we'd say that we know that x squared plus y squared is equal to r squared from our Pythagorean theorem. So if we wanted to solve for r knowing x and y, if we knew x and y to begin with, we could say just take the square root of both sides of this equation. And what we end up with here is this. We say r, which is the absolute value of the number, is the square root of x squared plus y squared. So this being said, we're going to use this formula quite a bit of the time, and it's pretty easy to use once you've got the hang of it. Okay, so it says find the modulus, okay, of each of the complex numbers that I've given us here. So we want to find these moduli, also known as the absolute value of these numbers. So I'm going to list them in several different fashions, but we say first of all we want to write this in standard form. So the first thing we want to do is write this as 0 plus 5 times I. So 0 plus 5i, we could say that our x part here is 0 and our y part is 5. So if I were to go graph this, for instance, I'd say go left and right none, go up 1, 2, 3, 4, 5. So we'd say that the number 0 plus 5i is this number right here. I'm going to draw on my arrow back to the origin. And we say that this r distance here would be the square root of, let me not put this over here, let me put it over here. We say this distance r would be equal to the square root of x squared, which is 0 squared, plus y squared, which is 5 squared. So we get really the square root of 25, which is plus or minus 5. We'll just keep it positive 5. So it didn't need, we didn't need to use this formula to basically figure out that the absolute value of this number is 5. We could have just drawn the picture and said, look folks, I can tell you that it's 5 units away from the origin. So likewise, when we look at this next number, we say 7, which is 7 plus 0i in standard form. We say its x part is 7, its real part is 7, its imaginary part is 0. So we go 1, 2, 3, 4, 5, 6, 7 to the right, up and down none. So we'd say that this is our purely real number. We're going to give this a name. We say this is 7 plus 0i. So getting the hang of this thing, really what we start to do is we just recognize x and y. And we say we know it's the square root of x squared plus y squared. So r, in this case, r, is just going to be the square root of 7 squared plus 0 squared, which is really the square root of 7 squared, which is the square root of 49, which is 7. So again, I didn't need this formula to tell me that r in this case is 7 units away from the origin. So the absolute value of this number would be 7. And then last but not least, 3 plus 4i. So now we have an x part of 3 and a y part of 4. So we say over 3, 1, 2, 3, up 1, 2, 3, 4. Now, little bit different this time. Here's our number, and maybe we should do this one in like a different color here, like a green. We say here's our 3 plus 4i, and it's this vector right here. And what we're interested in doing is finding r, which is the modulus of this number. So we'd be the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25. We could reduce this down to 5. So we could say that this is r equals 5, and it's 5 units away from the origin. So last but not least, what I want to do is I actually want to write these in absolute value notation. So letter A up here, we would say the absolute value of 5i, we said, was just 5, or the absolute value of 7, which of course when we graphed it is still 7. I mean, it would be 7 whether you're talking about real numbers or not real numbers, but we say the absolute value of 3 plus 4i is some number, and it is the distance 5 because that's how far away this point was from the origin. So that is how you find the modulus of a complex number in standard form.